2, 1. Okay, so this is kind of a little bit of a mini test on the quadratic functions in grade 11. Hopefully it serves as a nice purpose of deja vu for you on all of these different concepts related to quadratics when they are functions. So as usual in these types of videos, I'm gonna put the link to this file, okay? So you'll see it in the show notes. You can download it for yourself if you want. If you can't, find it doesn't work, you can always leave a comment for me and I'll follow up. And I'm going to solve the entire kind of little mini test in this case, so we can come back and see how you did. All right, so let's get started. Okay, so there is kind of one major question here, and the question is related to this function of a quadratic right here. So I'm going to copy this down for myself, and then I'm going to step through every single part. So part A, so within here, so I guess that is find the zeros of this function. All right, so that's the first thing that we're going to do. So in order to find the zeros of this function, well, what we need to solve is we need to set, okay, so our function is equal to 0, and we'll have 6x squared minus 5x minus 4, and we want to find the values of x such that, I guess in this case, the right-hand side equals to 0. Well, we can do it in two different forms, right? You can try to factor it. If you don't want to waste your time, you can always use the quadratic formula and solve it that way. Okay, I'm going to first try to see if I can factor this. So 6, and this is times, so this is going to be minus 20. So minus 24, the multiplication. So two numbers multiplied minus 24, and then when they're added up, they give me negative 5. And I guess, actually this is factor. So 8, or minus 8, times 3 is going to give me that. And then minus 8 plus 3 is going to give me that. All right, so this is factorable. Okay, so I'm going to do that. So 6x squared, so I'm going to decompose that negative 5x, so minus 8x plus 3x minus 4. And then let's group these things together. So factor, so this one first, and that's, I guess I'm going to take 2 and x out of there. It's going to give me 3x minus 4. And so that means that I'm not going to factor really anything out of the second one. So that's going to be that. And so I have 0 is equal to 2x plus 1 and then 3x minus 4. Okay, so I can get these factors out, and now finding the zeros is much simpler. So right here, so the 0 from that, so 3x minus 4, it's going to give me my first 0, which is going to be just x 4 over 3. And then from here, I'm going to get 2x plus 1 equals to 0. And so that's going to give me negative 1 over 2. So here are my two zeros, okay, of this particular function. So I have those. Now, if you're relating it back to the quadratic again, if you remember, so what does that mean? So these zeros just simply means that that's where the parabola is going to cross through the zeros. So the y is equal to 0. All right. And I guess in this case, so since the parabola, okay, so we have a positive, so this is positive 6. So it looks like, it's going to cross somewhere over there. And then those are your two values, so those two zeros there. So negative 1 over 2 and then 4 over 3. All right, so those are going to be the ones. All right, so that's part A. Now, I guess I'm going to do it in fast-forward fashion. I'm going to do it also in quadratic formula form. So instead of doing all of this, oftentimes you might just say, you know what, forget it. Let me just try to find what the formula gives me. So let me do that. All right, so I'm going to give the formula and then show you that we're going to get exactly the same answers. All right, so there you go. I basically just used it. Actually, it was a little bit more annoying than I thought, but that's okay. So here's the formula. I just substituted the values for A, B, and C from the quadratic. So those ones were coming from here. So A, B, C. Don't forget the negatives. And then just worked it out right here, and then simplified. Okay, and we got 4 over 3 and negative 1 over 2, which is exactly what we got through the factoring. So whichever one you decide. I mean, if it's a test, just go with your gut, unless the teacher tells you, whichever one. So I wanted to show you both, and I guess you can slow it down if you want. You can try it. So that was part A. Let's take a look at part B. Find the maximum or minimum of the function. Okay, so finding the maximum or minimum, it would be great if this was actually in vertex form, because then we can just find the maximum or minimum. Now in this case, we right away know, because the A is 6, so we know this is going to be opening upwards. So it is a minimum that we're going to be finding, not a maximum. Maximum, it would be opening downwards. Oh, you know what? Here, so for part D, it says put the quadratic in vertex form. Okay, so let's kind of do the two things in once. So let's find the vertex form, and then we'll find what the minimum actually is. Okay, so that's what I'll do. So again, let me, I guess, copy this down. Okay, so I'm going to first find the vertex form, which is, I guess, is going to answer part D, and then find the minimum in this case, because the A is positive. This one probably won't be nice. Okay, so let's do it. So the vertex form, so let's complete the square. So let's take the 6 out of there. 6x squared minus 5 over 6x. And we got to leave the negative 4 out. So now we're going to take our value right here. So 5 over 6 divided by 2 and square it. So that's going to be 5 over 12 squared minus 5 over 12 squared. And this gives me, so I have 6, that's going to be x. Okay, so it's minus 5 over 12 squared. Now we got to bring this 6 over here. So minus, so 6 and 5 over 12 squared. And then the minus 4 behind there. Okay, so let's simplify this. All right, so this is what we have right there. So my entire thing equals 6. So x minus 5 over 12 squared. So that's going to be my minimum, right? So this is the vertex form. So that's 1. So this is the vertex form. So we have that. So that means our vertex right here is going to be at 5, 12, and then 121 over 24. This is negative. And this is our minimum. So our minimum is going to be that. Okay? So you can find your minimum that way, and you can put it in. So that answers 2 of the questions. All right, let's take a look and keep going. Find the line of symmetry. All right, well, I guess we have this one as well. Okay, so the line of symmetry. So again, let's recall. Okay, so the line of symmetry. So basically, if I go back to this parabola, so line of symmetry goes right through the vertex, right? It's the value that we have at the vertex at this point right there. So since we now have, so for the line of symmetry, well, we have the x value. So the line of symmetry happens at this point, 5 over 12. And that's the line. It would be a vertical line straight up. So we actually, with this vertex form, as you can see, you can get the minimum, you can get the line of symmetry, right, which is super helpful. And obviously it's a lot easier to graph these things if you had to do it by hand, or at least approximate it in some way. Since we have the zeros, we have the vertex, we know how it opens up, we can definitely graph it, okay, if we like, or sketch it per se. All right, so now next, part E. So this one I guess is different. So let's take a look. So part E. Okay, so provide the first and second difference at those values. So -2, -1, 0, 1, 2. Okay, so let's do that. I'm going to borrow, let me borrow this. Okay, so the actual function. That's right here. And, okay, so we have, well, let me do this. I guess I'll do it in fast forward fashion here. So I'm going to fill this table up so that we have our x value, we have our f of x value, then we're going to have our first difference. This is going to be my first difference, this is going to be my second difference. So that's my x, this is going to be my f of x. All right, so let's do it. All right, so welcome back. All right, so I guess, so here are the values of x. This is f of x, just substituting them in, finding that. The first and second difference, so we're taking these and we're just subtracting them, right? So then it goes 1 by 1. So those are these, that's the first difference. Now it is a quadratic, so that's not going to be constant, but the second difference will be a constant in this case, and it's 12. Notice it's positive, which is telling us the parabola opens up upwards. Okay, and those were the first and second differences of this function. All right, okay, let's take a look what else they ask. F, state the domain and range of the function. Okay, so state the domain and range of the function. And so for this quadratic, and you know what, here I'm gonna go, I don't know which one will be easier for me. I'm gonna keep this vertex form in handy for myself, so I'm gonna copy it and paste it. Okay, because now why the vertex form? Because from the vertex form it's much easier to tell the range. Okay, so for a quadratic, the domain, unless the function itself is already restricted. If it's not restricted, then the domain actually is the set of all real numbers. So there is really no restrictions at all. Okay, so we can do everything. So positive, negatives, and zeros for this parabola. Now keep in mind again, so this parabola looks something like this, right? Now the range is all the possible values for basically f of x. And that's going to be, okay, so starting at the minimum value, so that's why I wanted to know what this vertex form is. So from the vertex form, so from the minimum, we have the range, which is anything above that, right? So we're going to have that the range, okay, for this, so our f of x is all these real numbers, but we are restricted that f of x will have to be greater or equal to the minimum, which is negative 121 over 24. It cannot be below it because that parabola doesn't exist there. Okay, so that's the domain, and this is the range for this particular quadratic. So that's super useful to have it in vertex form. Okay, what else do they ask? So we have, let the domain be restricted. Okay, so now they're restricting the domain for us. And so that's this right here. And it's restricted to less than 0. find the inverse of the function under the domain, and then state the domain and range of the inverse function if it exists. Now, of course, for quadratics, we have to be careful. So we have to see if an inverse function actually exists for x is less than 0. Okay, let me borrow this right here just to kind of guide you along and give you a visual. So let me copy this. So we have, so let me paste it. Okay, so we know we're supposed to, so we have this function right here. So this is our quadratic, so let me copy it. So we have this. Now it's telling us that we have our x is less than 0. Okay, less than 0. Now our vertex, so this point right here is at 5/12 and negative 121/24. So it's just a little bit to the right. So if I was drawing, so here, let's say if this was my y-axis, it kind of looks like this. You know, you have something like that. Okay, so where this is your x, and then you can think of this as your y. All right, and then this, so that because the line of symmetry, okay, that vertex is at 5/12, so it's a little bit to the right. And they're saying that the domain is basically, you know, all of this to the left, because it's less than 0. So we want to know all the values. So this will actually have an inverse because we're only looking to the right. So we're looking only at this piece going all the way up, right? Whoops, it's not straight. It's kind of like this, right? And then it just blows up. So that's the piece that we're trying to look for because of this restriction. So x is less than 0. So we're going to try to find the inverse of that. Since this is already in the vertex form, and again, for finding the inverse of a quadratic, the easiest thing to do is always to put it into the vertex form. All right. Now, it's already in vertex form because we've done it. Okay, so we have it here. So what I'm going to do is, let me switch this thing just because I don't like writing f of x. So I'm going to write this as y is equal to 6. Okay, so x 5/12 squared minus 121/24. And now let's rearrange this because we want to rearrange it for x and then swap the x and the y's, right? We want to rearrange this for that. So we're going to get y plus, oh boy, this is going to be ugly, 121/24, because I'm moving this over on the other side. Now, if the second thing is, so once you move that, so now we still have 6x 5/12 squared. So now I'm going to divide by 6 on both sides. This is why I'm saying it's going to be ugly. Okay, so we have this, so that gets rid of that. Now we're going to have to take the square root. Okay, so we're going to get square root of y plus 121/24 divided by 6. All right, and that is x minus 5/12. Okay, let's bring this over to the other side. Okay, and we're pretty much done. Let me duplicate this. And that's going to be plus 5/12 is equal to x. Okay, so we rearranged it for x. So this is going to be our inverse. Now remember that this is going to be plus or minus. Now which one are we going to pick? Right? So which one are we going to pick? Are we going to pick the positive or are we going to pick the negative one? Because we're only are looking at this piece right here. So this is the piece that we're trying to find right here, the inverse of that. All right, so we're going to have to try to reflect it back, okay, along the y is equal to x. Okay, and what is that going to be? So if you remember, Okay, so I'm going to kind of try to bring you back. If you have a parabola, and it looks like, let's say, like this, and let's say this is x squared. So because x squared is basically your parent of all quadratics. So if you have that, right, what happens is that this, this thing, let me duplicate it here. Can I? Okay, I'm going to try. Let's see. I'm going to take this. Let me select it and then rotate it. Okay, perfect. Because it's going to look something like that, right? That's the inverse. Now, of course, in our situation, we're kind of looking at this piece right here, right? So if you go back here, we're looking at that piece, which is less than 0. So we want to be able to find that piece. So we're going to be trying to find, so the piece that we want, the inverse is going to be this piece. Now, you might say, okay, how do you know that it's this piece and not the upper piece, meaning this piece? Well, we know because of the fact that it has to be reflected along this line, right? It has to be reflected along this line, somehow like that. I mean, this isn't the best reflection, but let me try it. Okay, kind of a little better. Okay, so it has to get reflected along that line. And that's why this one, I mean, this doesn't make any sense. This wouldn't be a reflection of this piece right there. So it has to be symmetrical. So we're going to be looking at this. So what we want, and within here, the bottom piece is always the negative. Okay? So that means we're going to be selecting the negative and getting rid of this piece. So that's going to be our inverse. But now we have to restrict it, because we originally had, okay, a restriction that we're starting here, which is x is supposed to be less than 0. So we have to find the 0 point. All right. So what is it? What is this 0 point there? So x at 0. So right here. What is that point? That's what we're going to be trying to find. And we can find it. So we have to go back to the original. Right, so this is a very hard question, but it's a great question to really test you on these inverses. All right, so we are restricting this to that. So I want to know what happens at 0. Okay, so f at 0 equals -4, right? So that comes straight from there if you substitute, because this is going to be 0, this is going to be 0, so we have -4. So that means this is the piece, right? That's my x and my y. Okay, so now for inverses, what do we know about inverses? We know that to get an inverse, what you're doing is you're going to be just swapping your x and y, right? That's what an inverse does. If you had a table of value, it would swap them. So what does this tell us? This means -4 and 0. That's going to be the point, the reflective point of this. All right. So what this is telling me, okay, so if I would draw it back out here, so we're going to be starting, somewhere. So this thing, as it gets shifted, okay, it's going to be starting at -4, and then it's going to be moving into this direction. So for our inverse, so coming back to our inverse, which is right here. Yeah, so this is my y and my x. Okay, so let me now swap them. So I will have, so y is equal to negative, square root of, this is x plus 121 over 24, okay, divided by 6 plus 5 over 12. And this is going to be restricted, so x is going to be now greater than -4. Okay, so it's going to be greater than -4. Okay, so that's what we're going to have. So it's kind of going to look, okay, I'm going to plot it. Hopefully, I think they ask us to plot, so we'll plot it in just a moment. So that's going to be our domain. All right, so we're going to see it. Okay, I'm going to plot it for you in just a moment. Okay, so our domain is going to be restricted to this. So it's x, all of that, and this right here. All right, and then the value will be, so the value, okay, so notice it when we swapped it, okay, so the value of it is 0, okay, so it's going to be maximum at 0, and then it goes down, right, and it just keeps going down, 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 down. All right, so my range for that is going to be, so my range within here, it's going to be, well, y, and that's going to be restricted. It's going to be less than 0. Okay, so that's what we're going to have. Well, let's check it out. Okay, I'm going to plot it out onto decimal so that we can see this thing, and that was a nice tough question for us. All right, so now that we have our inverse, okay, so we have our domain and then the range. Okay, so let's check it out. So I plotted it into, okay, so now into decimals. Okay, so let's do that so that you can see it. And I was doing that behind the scenes. Okay, so here it is. Okay, so I've plotted the function, so f of x. Notice the restriction, which is less than 0. So that's the blue one. So it's the kind of, it's not even half the parabola, because the original parabola that you had, so if I remove this, that was my original parabola, right? And then I am restricting it on this. And so notice that just below it, I called it h of x. That's your inverse. So I put that in there. And then that has the restriction, which is greater than -4. And you can see now the symmetry, okay, that this carries along the y is equal to x, because that's what we would want to see. And both are functions, okay, under this particular restriction. All right, so they have a certain domain and then they have a certain range. Now, the inverse just keeps going, gets bigger and bigger and bigger and bigger slowly, but it just keeps going and going and going. All right, so that's what you would have seen there. Okay, so that was an awesome question, super tough. Okay, if you got that one, great job. Now let's see what else they asked us here on this thing. H, so given the line, so now we have this H right here. So given the line, find the points of intersection between the function f of x and g of x. Okay, so that one isn't, hopefully isn't as bad. Oh my gosh. Got a little bit worried here. So it's trying to find the intersection between here, so this, and -x plus 2. So let's do that. So let's paste, and then I guess this was a g of x, -x plus 2. So this is a line, and this is a quadratic. So we're going to have something like this, and it has a negative slope. So it's going to look something like that. Okay, so there should be 2 points of intersection somewhere within here. So we got to equate these. So 6x squared minus 5x minus 4. This is where are these two lines or these two functions intersecting each other. So we have something like that. Let's bring this over to the other side. So 6x squared. It's going to be plus x, so it's going to become -4x. It's going to be minus 2, it's going to be -6, it goes to 0. And this one, I guess, well, I can factor this out. I can factor out a 2. It's going to give me 3x squared minus 2x minus 3, which is a little bit easier to work with. And we're going to find the zeros of this. Well, 3 times 3 is 9. Okay, you know what? I'm going to just use the quadratic, okay? Just to try to see and find those points. And it's probably not going to be pretty. Okay, so let's do it. So we have, so negative, So negative b plus minus square root, so this is b squared minus 4ac divided by 2a. Okay, so this 2 I can get rid of entirely. If you kept the 2 in, so if you were working with this, you just would get, you know, something bigger here, and you would have to reduce more at the end. So for now, what I'm going to do is, okay, so negative b, so that's going to be 2 plus minus, this is going to be 4 minus 4 times 3 times negative 3, 2 times 3. Okay, so what does this give me? I want to know this radical. So 4 minus, so that's going to be minus minus, so that's plus. So 4 plus 9 times 4, 36. So this is going to be 40. Oh man, this doesn't even work out very nicely. Okay, so it's going to be, and then 6 at the bottom. So what you have this. You have 2 over 6 plus minus. Okay, so let me just do plus first. Plus, okay, 40 over 6. That's one of them. That's one of the values of x. And then the second value of x is going to be 2 over 6 minus. So you actually do have 2 of them. And the radical of the 40, which makes this annoying. Now 2 over 6, this is just 1 over 3. Okay, reduced. So now I have my 2 values. And now if you wanted to find out the values for the intersecting point, okay, which is the, I guess, the y value or the f of x value at these points, you can find it by substitution. And we can substitute back into our original. So in this one, so if I copy this, so let's paste it. So we would have to literally, okay, so take this was a really mean question, okay, and then substitute it inside here to try to find what the value of f of x is. And then we would be able to find exactly, okay, so this point, and then this point. So we found the x values and then the y values. You know what I'm going to do is, let's see, I think it asks us to plot. Plot, okay, good. Okay, so, you know, so plotting, okay, well, the inverse we've already plotted, so we've done that. F of x we've kind of plotted. Now g of x. Okay, so let's plot that, and then let's see what those values are. Let me just kind of remove these for a moment. And let's replot this thing. Okay, so there you go. We were kind of right. So these are the 2 points of intersection on those. Now, of course, these are rounded within, but that's good enough. All right. So if you substituted them in and you worked everything out, that radical that you have in there, that square root, you're gonna at some point have to estimate it, right? So these two. So it'll be 1/3 plus whatever that is. Actually, let's check just to confirm. So it's 1 over 3. So 1 over 3. Let's say plus, and then this is going to be square root of 40 divided by 6. Okay, so that was one of them. So notice 1.387 and so on. Let's confirm. That was one of these. Yep, 1.387. Okay, so there you have it. So that was that value. And then you can do the same thing here, and then you will find both of them. Okay, so that was pretty torturous. All right, that was a great test. I mean, if you went through this entire thing and you got it, you know, you definitely had a great review and primed yourself for these quadratic functions. Okay, thanks for watching. See you in a future video.